Thanks everyone for coming. I appreciate everyone coming at the end of the day. I know it's probably been a long day, so appreciate you sticking it out. My name's Dan Gottlieb. I'm a clinical informatician and software developer, and I'm excited today to be able to talk about the FHIR Bulk Data API, which is an approach to working with population-level data in FHIR. Been co-leading this project for about 7 years with Josh Mandel since we started it. But I want to emphasize that kind of what I'm presenting today is really the work of many, many people in the FHIR community over many years. So not necessarily my work, but work of the community. And also that we've had incredible support from the Office of the National Coordinator for Health IT and the Argonaut Project, FHIR Accelerator, and the Smart Health IT project at Boston Children's. So lots of people really contributed to helping to advance FHIR in this way. So we have kind of a packed agenda. I feel like 45 minutes sounds like a lot of time, but there's a lot of stuff to cover around here, around the spec. So we're going to talk a little bit about kind of the goals of the API and where it's a good API to use and where you might want to use a different API, so where the boundaries are. We'll dig into the technical architecture, and I'll sprinkle in a little bit about kind of what was added in version 2 a couple years ago and what we're working on now as some ideas for version 3 as we talk about the technical details. I'll talk about the open source tools that are available for building on top of the bulk FHIR API. So one of the, I think, my favorite aspects about this project is that the community has really developed a great set of tools for both testing applications, building applications, and so we'll talk about some of those. This is a real API that you can use today in real products that are deployed at healthcare institutions. So we'll talk about adoption. I think that's a piece that I always wonder about when I hear about an API, so definitely want to get into that. And then we'll talk about kind of where we're thinking of going with the spec and how you can help influence that and get involved. So when I think about FHIR APIs, I often think about kind of 3 levels of data. So the smallest set of data would be data about a single patient. So you could imagine like a risk calculator that's a smart on FHIR app and is embedded into an EHR. And there you're pulling down data on the single patient, and that works really well with the FHIR REST API. You get very quick results, no problems. Then you get into kind of panel level data. So you might have a provider who has 1,000 or 2,000 patients in their panel. And so if you imagine the same kind of risk calculator, but now you want to stratify your patients in your panel and reach out to the high risk patients who haven't had a recent visit. So there you might be pulling data on all these patients down. And you can use the FHIR REST APIs for that, but you have to start to be a little clever around how your API calls are structured and which elements are returned and how you parse them. And then if you get kind of to the next level where you might be pulling data on 100,000 patients or 1 million patients or several million patients, at that point the REST API really breaks down. It's not really intended for that. And those are the types of use cases that we were focused on when we were thinking about kind of structuring a population level API on top of FHIR. And there are a lot of use cases where you might want those kind of levels of data. I won't go through all of these in the interest of time, but I did want to highlight a couple of them that related to projects that I've been working on. I work a lot in the research space, and a really interesting use case is you might have a cohort of patients and you want to look at data for people who are in your study. And so you want to pull that into an analytics environment, a data warehouse, maybe from there into R or Python to do some analysis of those patients. And so in those cases, you want to be able to get that data on the entire population. I actually changed this next one to be a little more buzzword compliant. I used to say ML training. Now I say AI training so that I can fit in with everyone. But it's a real use case where you want to get a lot of data out of an EHR or out of a clinical system to be able to train a model or fine-tune a model. And FHIR is great for that because you have your structured data in FHIR, and you can pull your clinical notes in as unstructured data in as FHIR document references. So you can kind of get all the data you need to train your model in FHIR. And so that's another great use case for a bulk API. The third one I want to highlight is kind of flips the paradigm a little bit. So I've talked a lot about getting data from a clinical system out. This is about getting data into a clinical system. So a really neat use case is saying payers have a lot of data on where patients get care outside your healthcare system. If you could pull that into your healthcare system, you'd be able to get a more 360-degree view of your patient. And we'll actually talk about a real implementation of this kind of towards the end of the presentation. And then there are many, many other use cases. I'm sure you can think of some that you've worked on as well. And the goal of the bulk data API was not to invent a lot of new stuff. We were really trying to say, hey, FHIR has all these great components. How can we put them together in a way that really supports these large data set use cases? So we still use FHIR resources as the data model. So you can use kind of all of the standard FHIR parsers. You can use the FHIR documentation as your data dictionary. If an EHR or a system has already mapped data to FHIR, they can reuse all those mappings. So you get, it's just FHIR resources. They're just come in a different way. We use the FHIR Operations API as a standard way to kick off data extracts. So if you've ever worked across multiple healthcare institutions, you'll know that every healthcare system, EHR, has their own way of starting an export. And so the neat thing about using FHIR for this is that now we have a standard way to build a client, and you ask for the data in the same way at every site. That's maybe a little bit of a rosy picture, but it's close. And then the last piece is around the security model. You have the same challenge where every site would have their own approach to security inside for requesting data extracts. And so here in bulk data, we use something called Smart Backend Services Authorization, which is kind of a machine-to-machine authorization mechanism. And we'll dig into a little bit about what that means later in the presentation. But if you're familiar with Smart on FHIR for apps, it's a little bit different in that this is really structured to enable machine-to-machine interaction after the initial setup without kind of user logins each time. So it's a little different flavor of Smart than you may be used to. I think it's also worth talking a little bit about kind of what's out of scope for bulk. So certainly one of the things that's out of scope is kind of the legal framework. So this is a technical specification, and it assumes that both parties have the ability to share data with each other. So that may mean that you need to have data use agreements or service level agreements or business associate agreements in the United States. So different legal pieces need to be in place in order to do bulk data. And then once you have that, then you kind of open up these connections. And there's actually a neat step in the authentication setup stage where you can kind of check that those legal agreements are in place before authorizing an app. Bulk is also really oriented around kind of batch passing of data, so we don't really focus on real-time data. That said, if you have a use case where you need real-time data, you can supplement bulk using other mechanisms in FHIR. So if you imagine like a care management app where you want to do a nightly backload of data from your one or more EHRs using bulk data, you could load data that way, and then when a care manager pulls up an individual patient, you can make FHIR REST API calls for that patient to see if there were any encounters or new labs that came in subsequent to that backload. So there are ways to kind of get more real-time data and still use bulk for kind of your more batch transactions. And then I think there's certainly opportunities to use subscriptions in a similar way so that you don't have to even make REST API calls. You can have data flowing in kind of between bulk updates. We don't directly address patient matching in bulk. That said, you can all the identifiers you might use for patient matching can pass through bulk. So if you're a payer, you're getting a bulk file from a provider organization, and you want to match patients based on subscriber number, that can flow through in the patient resources in your bulk export. There's also some neat work that I have a link to at the end of the presentation that just started this year around bulk matching, which provides a mechanism for using the single patient FHIR matching operation across multiple patients at a time. And so you could imagine a use case where you would match a set of patients, get back patient IDs in the system you're matching to, and then use those patient IDs in your bulk request to scope that bulk request to only the patients who you've matched. So there are ways to kind of manage patient matching around bulk, but it's not directly part of your bulk export. And then the last piece is around data transformation. So in general, what people are doing is using bulk as part of a data pipeline. And so if you, for example, want to translate between terminology systems in your bulk export, you wouldn't do that directly as part of your bulk operation, but once you have these bulk files, you can then do that directly using kind of off-the-shelf tools. And there's actually some neat open source pipeline tools that we'll talk about too that can help with working with the data once you have done the bulk export. All right, so we're going to shift gears a little bit and talk about kind of what happens in a bulk export and how the technical piece works. And oh yeah, so stepping back, I wanted to just mention there are a couple versions of bulk. So we put out version 1 in August of 2019, and then in November of 2021, we were able to put out a version 2 that basically took what we learned in version 1 and added, kind of shaved off the rough edges. So incorporated early implementer experience is what I wrote. In version 2, though, is completely backward compatible to version 1. So what you actually see in the wild is either version 2 servers or version 1 servers that have some version 2 features. So it's kind of a mix. And I'll try to highlight some of those as we go through. And then there's currently work going on through the Argonaut project to help develop ideas for a version 3. So the Argonaut project is focusing specifically on ways to make it easier to generate exports quickly. So helping on the streamline things on the server generation. And we'll talk about, hopefully if we have time, what some of those initiatives are. So digging into kind of what exactly happens in a bulk data request. We're going to go through this diagram here. On the left side, we have a bulk data client. So this is the system requesting the data. So here I might think of like a cron job that runs nightly to pull in fresh data from a clinical system. And then on the right is the bulk data server. This is the system that's providing the data. So you might think of an EHR here or a clinical data warehouse that has, or a claims warehouse that has some data that the requesting system wants. So it starts with a kickoff request. There are kind of 3 types of bulk data kickoff requests you can do. The first is at the patient level. So this would be requesting data from a server that's contained in what in FHIR language would be called the patient compartment. So FHIR resources that are associated with a patient. Second type of operation is a group export. So here we're kind of leveraging the existing FHIR API that lets you define groups of patients in different ways. Once you have a group, you can use that group ID and say, hey, export all the data that's available for this group of patients. So it's similar to the patient level export, but scoped to a group. We also have an operation where you can export all data on the server. And the distinction here is that this would include data that isn't associated with the patient. So you might think of things like value sets. And we added this FHIR value sets. And we added this basically to give a way to back up a server or to transfer data between servers. The last piece is actually not a kickoff request specifically, but is a header you would provide with your kickoff request. And I wanted to highlight the fact that bulk export requests are asynchronous. So if you think about a FHIR REST API request, you make a request and you get back some data. In a bulk request, you make a request and that request is really initiating a job on the server that will eventually result in some data, but doesn't immediately result in some data. So that's important to note. So we pass in this prefer respond async header to let the server know that the client's in sync with this, or is aware that this is going to be an async request. In version 1, we only allowed HTTP GET operations. In version 2, we added support for also HTTP post operations. And in fact, this is like the preferred mechanism going forward. There are a number of features we added in version 2 that only work with post requests. So in general, unless you have a legacy environment, I would suggest making your bulk requests, kickoff requests using HTTP post of a FHIR operation. There are a bunch of parameters you can provide as part of your kickoff request that kind of scope the data that's going to be returned. The first is output format. This doesn't actually scope the data. This is around the format of the data that you'll be getting out of the bulk data export. By default, or under the spec, kind of all servers need to support a format called NDJSON. We'll look at an example of that in a little bit. But servers can also support other formats including binary formats like Parquet if they choose. So NDJSON is kind of the base. You can always assume that'll be there, but maybe there'll be other formats. Although this, to be perfectly frank, I haven't seen a lot of servers offering other formats yet. There's some work going on under the SQL on FHIR project around trying to develop a standardized Parquet format for FHIR, and I could see that resulting in more use of this parameter. _since is a really important parameter. This lets you specify a timestamp for the data, so you'll only receive data that was modified after the timestamp. There's actually a place in when you retrieve the data, which we'll look at, where you get the server's timestamp for that data. And so you could take that timestamp and pass it into your next request to only get data since your last request. So that's a pretty common pattern for data extraction and ETL, and so the _since parameter supports that. _type lets you specify only specific FHIR resource types to be returned. So if you have a use case where you only care about lab results and patient demographics, you could specify the observation resource and the patient resource so that you're not getting a lot of data you don't need. A few of you will probably have realized that that's not exactly true because observation includes more than just labs. And so that's where the next parameter comes in. There's a parameter called type filter, which lets you use FHIR REST API search parameters on your bulk data request to filter the data further. So here we could say observation, we only want observations that have a category of lab. And so overlaying that, we would get all patient demographics, but only a subset of the observations back. This is an experimental parameter, but some of the work that the Argonaut group is doing this year is around specifying that a little more tightly and making it a formal part of the spec. This is actually already implemented in production in both Cerner, Cerner and Epic, as well as other systems, including a lot of open source and commercial FHIR servers. So this is something you can use today, but right now it's not very tightly specified in the spec. So we want to make sure that that gets improved. A few more parameters I'll run through really quickly that we added in version 2. You can pass in an underscore elements parameter. This is a regular FHIR search parameter that lets you restrict the fields in the FHIR resources that are returned. Again, trying to just limit unnecessary data that's coming back. The patient parameter lets you specify specific patient IDs that you want data on, which enables some neat parameters where you pull some data, do some analysis, and then request more data on that's the subset of patients that you're really interested in. And then we have a parameter called include associated data, which lets you request metadata about the resources that are being returned. In this case, it's mostly been implemented really around returning provenance resources that are related to the resources you're getting, since that was a requirement under US Core. All right, so that was a lot of talking for just the kickoff request. I think they get faster. So we've made our kickoff request, and as we discussed, you won't get back any data. Instead, you get back a content location. So that comes in as a header. So you get a status of 202 accepted. The server has received your job. Of course, you might get an error status and an error here if you had a problem in your request. But here we're getting a content location, which is a URL to kind of manage this export job. So let's say we hit that URL, that content location. What we would get back is a status. And so in this case, we see our status is still 202 accepted. The job isn't done yet. And we get an X progress status, which is kind of a human readable text that you might use for logging, which is basically the server communicating to you where it is in the job. And different servers will return different text here based on their capability. So a server might just say in progress, if that's all it can tell you, or it might say something like 50% complete or 100,000 of a million resources generated. The key header that is computational here is retry after. So servers can provide clients with hints on when to check back on the job. So in this case, the server is telling us that in 2 minutes, 120 seconds, we should check back. It thinks the job will be done. And so this is a way for servers to communicate to clients. You don't need to continuously poll us. You can wait until the job is done. So that's why we wait those 2 minutes, because we're a well-behaved client. There's also back-off options in the spec. But we're a well-behaved client. We make that request again 2 minutes later. Since the job is done, instead of getting another status, we'll get back a JSON manifest of kind of where our generated files are living. And so here I put some numbers on the left. I'll go through just kind of some specific points on here. So the first is that transaction time. So this is the server saying that this data is as of a particular timestamp. And that's where you could take that and use that in a subsequent request to say, I want data after this data set. The request is mirrored back in 2. That makes less sense if you're doing a post request because the URL is just not that interesting. It doesn't have your data in it. So that's kind of deprecated. We'll probably take that out at some point. The number 3, though, is important, which is requires access token. So I've been kind of skipping all the authentication. We'll talk about that in just two slides or so. But each of those requests that we just made do have to be authenticated. Some servers are putting files at a highly entropic URL, so a URL with like a secret URL, and don't have authentication on top of that. And some servers do have authentication on top of the file. So this parameter, or this field, tells you whether or not you need to provide an authentication token when trying to retrieve these files. And then 4 is kind of the main part of the response body here, the output array. These are the actual files of data that have your bulk export data. You can see they're organized by this type field here tells you the resource type in each file. And you can have more than one file per resource type. So here we have one file of patient resources and 2 files of observation resources, which is somewhat realistic. We usually get a lot more observations than, several observations per patient. Based on the spec, you'll only get one resource type per file. And the idea there is really to be able to support efficient ETL operations where you're kind of operating on one type of data. There's some work happening in the Argonaut project this year to look at ways to organize data by patient instead of by resource type, and I'll talk a little bit more about that towards the end. Number 5 here is a deleted key. This is where a server can communicate to a client that previously sent data was kind of sent in error. So data that the client received on resources that the client received should be removed from the server. This is a little different from things that are logically deleted, where you might have a resource that's tagged as entered in error. Those should really probably be in the main body of your resources as an updated resource with a new status, rather than as a deleted resource. This is really about telling a client, take these resources off your system. And then the last key is a little bit misnamed. Number 6 is error. That's really just operation outcomes associated with this export. And so it can include things that are at the information level or the warning level, not just error. But the idea there is if you have a job, let's say you're exporting data on 1 million patients, and the server's unable to retrieve data for 2 of those patients, the server may not want to fail the whole job, but wants a way to communicate to the client that those patients' data wasn't retrieved, or maybe even a subset of data for patients. And so the server here can provide a NDJSON file, 1 or more NDJSON files, of operation outcome errors that communicate that. Of course, the server always has the option of just failing the whole job, and could, instead of returning this whole manifest, could have returned an error status code and an operation outcome for the job. So it's really up to the server to decide if it wants to treat every error as catastrophic or where those thresholds are. So last piece, now we have these NDJSON files, and we can just make requests and retrieve them, and then we'll have some data. And the data kind of looks like this. This is an example of some JSON, and I've put a little circle and X or line through parts that you might expect to see in JSON that wouldn't be in NDJSON. So and in FHIR, it might be actually even more boilerplate because it might be wrapped in a bundle usually. But in JSON, you have kind of all this punctuation, and which is to kind of put it into an array. But in NDJSON, you basically have JSON objects that are separated by new lines. So every line is a new object, and in this case, every line is a new resource. And so that is a small change, but it really changes how you can process the data. So instead of having to load the entire file into memory to parse it, I can actually read one line at a time or write one line at a time and read or write it in a streaming way. So it turns out to be a pretty good format for large data sets. The other neat thing about JSON is you'll notice this is very verbose, right? You get your field names on every line. But in gzip compression on the web is super efficient because browsers do it every day, all day, and that actually kind of compresses out all these repeated fields. So if you do gzip your NDJSON, you can actually get pretty small, pretty efficient file sizes for very large data sets. So there are other formats, Parquet would probably be smaller, but NDJSON turns out not to be a terrible way to transmit large data sets. I promised we would talk about authorization, so I want to talk a little bit about backend services authorization for smart backend services authorization, which is what we use for bulk. There's an out-of-band registration process, so basically a client goes to the server and registers the client's public key with the server, or a public key URL, which is actually a little better because you can do key rotation. And then the server gives the client back a client ID that the client can use in requests. And then when the client wants to make a request, like our kickoff request, the client would go to the server with a sign a token with its private key, send it to the server. The server would use the public key to verify the client's information. That token includes that client ID, so it knows who's making the request. And then the server can provide a short-lived access token back to the client that's passed as a header in the actual request. So all those requests that we talked about would have this header. When the token expires, the client just can go and request a new one, and then remake the request with that new token in the header. So these tokens are fast to request and can get re-requested as the job goes on. So this is just a visual kind of representation of that. You have this initial step where you do the setup. And this is what I was talking about, where you might want to, this could happen through a portal or it can happen more manually. But this might be where you would verify that this client actually should have access to these FHIR resources or should have access to the server prior to giving them kind of a client ID and turning them on. And then in subsequent requests, you make a signed token request, get back the token. This could happen many times over the course of a very large export where it takes a while to generate the files. The tokens may expire. You'll request a new one, make a status request, wait a while, and request a new token again. So we went through that pretty fast. There are a lot of steps. I put together a Python tutorial as a notebook that kind of builds a minimum client with authentication. It doesn't have any error handling. Don't use this in production. But if you want to play with the flow a little bit, it kind of provides a step-by-step way to do that. And all these slides are online. I think they're also on Whova. So you can find the URLs there. I mentioned we would talk about open source tools. I think there's really a great ecosystem here. So one of my favorite tools is the Smart Server Reference implementation, which is built and maintained by Boston Children's Hospital, the Smart Health IT team there. And this is a neat server in that it's not a great FHIR server. It doesn't work well as a real server, but it's a very configurable test server. So you can actually make this server into whatever you want it to be to test a bulk client. So you can specify that you want it to be fast, or you want it to be slow, or you want it to return a lot of little files or very few big files. You can even have it inject errors at different points in the process. So you can say, I want to fail authentication. I want to fail, I want one of these files to time out. So you can have different scenarios that are built into the server and test a client against those scenarios. So a really cool tool. The Smart team also maintains a sample client. And this is great if you want to connect to a bulk server and test it out. But folks, it's open source. But all these tools are open source. And folks are also using this as a starting point for building a custom client for a specific data pipeline. So there are two instances that I'm aware of that folks have built production clients kind of on top of this open source client. So it's also a good starting point. I think it's a JavaScript client, if that's the language you prefer. Another really neat bulk tool is maintained by the Office of National Coordinator for Health IT in the United States called Inferno. Inferno can test a lot of FHIR stuff and is a really kind of a neat project overall. But it also has a really good bulk server tester. So if you're built a bulk server, then you can actually put your URLs into this test tool, which is open source, so you can run it locally, or you can go and use their online version, and it'll test your server against the spec and tell you where there are gaps. So really neat tool there. You may be wondering, who builds servers? There are very few people who build servers, FHIR servers. But actually on the bulk side, a lot of folks are building a facade in front of a data warehouse that might support bulk to enable folks to access their data warehouse without having to kind of figure out how to connect. And so in those cases, you might actually end up building a bulk server, even if you're not a FHIR server developer per se. A tool that I built a couple years ago is called the FHIR Data Census Tool, and this is really designed to work on a small subset of FHIR data at a time, so it doesn't really scale to kind of a very large data set, but if you pull out a sample of your data, it'll show you kind of visually what's in your FHIR data set, which elements are populated, how often they're populated, for repeating elements, how often they repeat, what codes are used, what systems are used. So it's a neat way to kind of get a picture of a bulk export and try to understand what's populated. Along that vein, I actually have a talk tomorrow that I'll advertise around open source tools for FHIR data quality. So I've been working with Boston Children and the NIH and the ONC on some open source tools to be able to to have a standard way to assess data quality in a FHIR data set. This is designed to scale up to very large data sets and is some really neat work. So if you're interested, please look that up. Okay, so shifting gears a little bit again, I want to talk about adoption. This is, I think, my favorite slide in the whole presentation, because when I started talking about bulk, there were no implementations, so I couldn't really show this. But now there are a bunch of implementations, which is great. So most of the open source FHIR servers and many of the commercial FHIR servers support bulk. And because the bulk is a certification requirement for EHRs in the United States, many of the EHRs support bulk, including some of the largest ones in the United States, Epic, Cerner, Meditech, but almost all of the EHRs that have a large US usage support the bulk API. So that's great. They specifically, under regulation, have to support the group export at the bulk level. So it may not be the entire system, but there are ways to create groups in most of these EHRs that you can then export using the bulk export API. And then another great early adopter of bulk has been the federal payer in the United States called CMS, Center for Medicare and Medicaid Services. Thank you. Got hung up there. Yeah, so the federal payer in the United States has been a great early adopter. They have 3 pilot projects that use bulk. One of the ones that I think is really neat is called data at the point of care. And this is what I was talking about in one of the use cases. What they're doing is making claims data available to healthcare providers for their patient population. And so they can pull down that data in bulk and load it into their EHR to be able to see care that patients have received outside of their health system. So if you wanted to see if your high-risk patients have received flu shots, maybe they got a flu shot in a pharmacy, and so you wouldn't have any way of knowing that. But if you were able to pull down this data from CMS, you can kind of load that in and be able to see that in the patient's context or when risk stratifying patients. So I think this is a really neat use of bulk. So I mentioned I would talk about the Argonaut project. So Argonaut is one of the FHIR accelerators, and this year the Argonaut members have decided to focus on kind of some ideas for version 3 of bulk, specifically around making bulk easier for systems to generate and more efficient in some use cases. So we've got kind of 3 projects underway, and we might do another 1 or 2 depending on time. So the one we've kind of completed and it's going to get rolled into some proposed changes to version 3 are, I mentioned this already, is removing experimental status from type filter and tightening up the language around implementation. This is kind of a no-brainer because it's already implemented in a lot of production systems. What we're working on now through a series of meetings is looking at how we can output data organized by patient. So you have some use cases where the clinical system may be storing the data kind of organized by patient, and the client may want to load the data by patient. And so forcing the clinical system to split out the data into FHIR resources and then the other system to put them all back together to be able to load the data doesn't make that much sense. And so we're looking at kind of how we would make that unnecessary. And then the third project that we haven't started yet is really around thinking through if there are some things we can standardize around group creation and group management, so that I always think about research use cases, as I mentioned, if you're doing a study across multiple institutions, you may want the same cohort of patients to be exported from each institution. And so right now, because group is kind of handled at the system level, you'd have to specify that differently for different sites. It would be really neat if there was an API where you could kind of define that in a computational way so that you're certain you're getting the same patients with the same characteristics from different sites. So I think that's going to be a really neat project. This is an open effort, so we have a wiki page if folks want to start joining the calls and participating as well. And then if you're interested in bulk data, I encourage you to work on implementation. So now that these systems are starting to roll out in production use cases, there's folks coalescing around different use cases and starting to build out infrastructure for those use cases. So if you have a use case for bulk, I'd encourage you to go on Zulip, go on FHIR Chat, and ask if there are other folks who are working on that use case, and maybe there's some opportunities for collaboration. I'd also love to see more open source pipeline modules. So, once you have the data, you want to be able to kind of clean it up and do different things with it. And it would be great to see, as folks are developing tools, if they can work with the community to develop tools that can be used in multiple contexts. I mentioned the data quality tool that I'm going to talk about tomorrow. That works directly off of bulk export files. So you can kind of put that in a pipeline and monitor your data quality over time. Microsoft has a really neat anonymization tool that's open source that also works directly on the ND-JSON files that come out of bulk export. And so you can kind of put that in your pipeline, get a bulk export from a system, anonymize it, and then pass it on to another system. And so it's nice that these tools can kind of plug and play like Legos. In terms of getting data into another system, there's been some kind of very early work on a bulk import, on approaches to bulk import. In particular, the UDS Plus implementation guide has really taken that forward. And so the idea here is to figure out standard ways you can request a system ingest some bulk data that you've exported from another system. And I think that's a really important area, so I'm glad folks are advancing that. I mentioned bulk patient matching. Started work with a group of folks, particularly in the Helios FHIR Accelerator this year, around drafting a proposal on a way to match a bunch of patients at a time and get back their demographic information. And the idea here is to be able to figure out the patient IDs in another system so that you can then request additional data on them, either using the REST API or the bulk API. And so I think if you're interested in that, please check out that IG. And then the last piece, the last thing, other project I wanted to talk about is the SQL on FHIR effort. This is a really cool project to work on ways of standardizing the use of FHIR for analytics. If you're interested in that, there's a couple talks about that on Wednesday morning. So there's like a whole SQL on FHIR block. And I think the team is working towards version 1 of that. So we were actually talking about that earlier today. So it's still early stage, but it's advancing. And I think there are a lot of pilot implementations. So definitely a neat project to take this bulk data and then actually use it for analytics once you've exported it using bulk export. So I'll end there. There's the bulk data implementation guide is kind of the core resource to check out if you're interested in learning more. There's the reference server implementation, and then most of the kind of discussion about bulk data happens on FHIR chat called Zulip. So if you're interested in that, we have a bulk data stream as well. And then lastly, I'll just put up this link. So these are the slides that I just presented. They have a lot of other links in them. So if you want to get a link, this is the one QR that you need. And then FHIR has a feedback link too. So I'll leave it there. Happy to answer any questions or if folks have comments or thoughts.
Thanks, Dan. Let me just read one from Huva real quick, and then we'll go around the room. The question is, why the output format and not content negotiation with the accept header, or are both supported?
That's a good question. So the challenge is that there's a lot of intermediate representation. So when you do the content the content type negotiation, you're negotiating for the content you're going to get back right away. And what we're saying is the output format is what you want like 12 steps down the road once you've kind of checked your status and gotten your manifest in JSON. Then you want to be able to receive ND-JSON files. And so that was kind of why we went with having an output format, because it's not the content you're getting back, it's the content of the files you're going to get back down the road. That said, there is content negotiation on the ND-JSON files. So, and this is something we need to actually tighten up in the spec. So it's something that certainly would like some input on, and something we've talked about a little bit in some of the Argonaut meetings this year. And I think there's maybe a long thread somewhere on Zulip about this as well, which is, how do you negotiate gzip compression on top of the files you're about to retrieve. So if you have an NDJSON file and you're requesting it, the server might or might not be able to provide different compression formats, and so you can do some negotiation there. The reason there's a discussion is that some servers may not be able to do that negotiation. So if you have files that are hosted in a static cloud bucket, then those files are in whatever format they were generated in and may not be going through a server again before you receive them. And so content negotiation gets tricky there. So we were talking about how to handle that. I don't think we've landed on a great solution, but that was probably a more verbose answer than folks are interested in. But it's a really good question, and it's the core reason is that you're not negotiating the content you're receiving right away.
I imagine a pretty big use case, as you mentioned before, is cohort building. But with that being said, I'm not sure what functionality that the bulk API supports for filtering or like advanced filtering. Mm-hmm. For example, there's FHIR. I'm not sure if that's supported natively or it would have to be applied on like a later transform to the data.
Thanks for asking that. So there's a parameter called type filter, which lets you apply the FHIR REST API parameters, which are not quite at the level of granularity of FHIR, although they're kind of a limited representation of FHIR, so they all map into FHIR, but they're a subset. So that's kind of how you would filter the data. You can also, of course, I think this was maybe implied in your question a little bit, do downstream filtering using FHIR on the data you get back. But because we wanted to support a lot of different servers with different capabilities, we didn't want to make FHIR a requirement for supporting bulk data. Actually, kind of a related project is in the SQL on FHIR work, which is very FHIR based. There's the idea eventually of either in the bulk operation or in another operation being able to pass in what's called the view definition, which is kind of a FHIR representation of data, and get back data. So there are ways where we might use FHIR more in the future, but right now it's really REST API parameters, and then you could do further filtering with FHIR after.
Yeah, hi. So you had mentioned that client request information that may come later, and that you had mentioned that client requests and hopefully they're well behaved. And my question is, why not alleviate that whole concern and then when server is ready, notify the client that come get the content or put it out there? So, yeah.
Yeah. That was also something that we went around a lot on in the design. So like you could imagine a scenario where you'd use FHIR subscriptions or webhooks to kind of notify the client directly. The challenge, there are certainly, and that would certainly work for some clients, but there are also clients where that wouldn't work. So clients behind a firewall or within the firewall at a healthcare institution might not have kind of an endpoint that the server could ping. And so we kind of went for kind of lowest denominator in version 1 and 2, and saying like everybody can poll, not everybody can receive a notification, an inbound notification. I think there's certainly an opportunity, like as people explore use cases, if the polling becomes a pain point, I think it's worth kind of reconsidering that, because it's certainly, as you said, like much more efficient than polling. On the other hand, like in general, what we've been finding is that there's like very few jobs and they're very long running, and so to date, at least, servers haven't been getting kind of inundated with a lot of requests. These are usually very highly selected clients, right? Because you're passing large amounts of protected health information, and clients that are running kind of a small number of large jobs. And so the polling is not optimal from an engineering perspective, but seems to work well enough and works everywhere. So that's kind of why we landed on that.
Hi. So you talked about the standardization of group creation, cohort definition as part of the bulk optimize. I just want to check if you're working with DaVinci member attribution kind of implementation guide, just from the point of view of interoperating with that approach, because a lot of cohorts are going to be defined from payor for certain payor use cases. So can you speak a little bit about that?
Yeah, so that's a project we haven't started yet, so there's a good time to bring it up. There's certainly been folks from Da Vinci attending the Argonaut calls, and so please send people our way, specifically on ATR or kind of other projects where you think there may be applicability. Because, we want to make sure we cover as many use cases as we can. So I don't have a good answer yet, but hopefully, if we do this talk in another year, we can talk about how we sorted out group creation.
Well, thank you. That's all the time we have for questions. But if you want, you can put questions in Hoover, and someone from the team will answer them, or Dan will answer them.
Yeah, I'm also happy to stick around for a couple minutes. I saw there's some folks who we didn't get to with the microphone.
Thank you.